Let's do some more graphing of rational functions. So in this example, we're going to graph y equals 2 over x squared minus x minus 12. The first things that we need to find are our vertical and horizontal asymptotes. And in order to do that, we should be factoring anything that we can. So let's rewrite this as y equals 2 over x minus 4, x plus 3. And if you remember from the previous lesson, the vertical asymptotes come from whatever makes us divide by 0. And that would be, in this case, x equals positive 4 and negative 3. So let's find those. X equals positive 1, 2, 3, 4. And draw a vertical asymptote in there. And negative 3. And draw a vertical asymptote in there. Okay. Okay, for horizontal asymptotes, we're going to compare the degree of the numerator with the degree of the denominator. Actually, in this factored version, it's a little bit harder to see. Perhaps we should look up here. The degree of the numerator is 0 because there's no x's in the numerator. However, the degree of the denominator is 2. In the denominator, we have 2, so let me erase that if I can. I can. Since the numerator has a smaller degree than the denominator, that means that y equals 0 is our horizontal asymptote. So we have a pretty good idea of where our asymptotes are now. Okay, next thing to find is our intercepts. So remember, when you're finding let's say you're finding your y-intercept, you're going to set x equal to 0. So it doesn't matter whether you put it into the factored form or the original form, either one is fine. But if we plug in y equals 0, we're going to get y equals 2 over, let's plug it into the factored form, 0 minus 4, 0 plus 3, or 2 over negative 12, which is negative 1/6. So we have the ordered pair x is 0, goes with y is negative 1/6. So let's plot that. X is 0, is right on the y-axis. Y is negative 1/6. I'm going to exaggerate just a little bit, just so we can see it. Okay, and then to find the x-intercept, and this is a really important part. To find our x-intercept, we would set y equal to 0. And just like in the previous problems, in the previous video, when we set y equal to 0, we have 2 over x minus 4 times x plus 3. If you multiply both sides by that denominator and clear the fractions, what you get is 0 equals 2, which is not possible. So that means that we have no x-intercept. And this happened quite frequently in part 1 of graphing rational functions. That's actually really, really helpful. That tells us that our graph never crosses the x-axis. So immediately we can tell what the inside portion of our graph looks like here, where we have negative 1/6. If our graph is never allowed to touch this x-axis up here, and it has to be sucked closer to those asymptotes on the right and the left of negative 1/6, then I know that our graph must do that. If our graph did this, or maybe went the other way, it would have an x-intercept. And we have that it does not have an x-intercept. So that's how I can tell that the graph must go, up and down through negative 1/6. Okay, to figure out what's happening to the right of x equals 4 over here, and to the left of x equals negative 3 over here, we're just going to plot a couple more points. Now you could pick, let's say, x equals negative 4 if you want to, but I kind of like to exaggerate, so I'm going to pick x equals negative 10. So let's do plug that in, y equals to negative 10 minus 4, negative 10 plus 3. And you'll notice I'm plugging it into the factored version just to help the mental arithmetic. So 2 over, negative 14 times negative 7. Now, I don't know what 14 times 7 is, but I do know that negative 14 times negative 7 is some positive number. And 2 divided by some positive number is positive, which is really, really helpful. At x equals negative 10, so way over here is negative 10, we have some positive y value. Now remember, we have no x-intercepts, so the graph cannot touch the x-axis, and our graph has to behave according to those asymptotes, so our graph has to do this. It has to get closer and closer to the green y asymptote, horizontal asymptote at y equals 0, and it has to get closer and closer to the red asymptote up here at x equals negative 3. Likewise, when I plug in x equals, let's say, positive 10, give myself some space here, and let me clean that up just a little bit, otherwise it looks like a 16, which would be fine, but I want it to look like a 10. When we plug this in, we've got y equals 2 over 10 minus 4, 10 plus 3. Again, I'm plugging it into the factored version. I have y equals 2 over 6 times 13. And I could get out my calculator and figure out 6 times 13, but what I really care about is this is a positive number. And since I am way over here at x equals 10, and I know I have a positive y value, I know I'm up there, I also know I can't cross the x-axis because I have no x-intercepts. So the graph must look like this. Okay, let's do another example so we can practice that. So let's graph in this example y equals 2x over x squared minus 9. Now remember, just like in the last example, when we're finding our asymptotes, the first thing that we want to do is factor anything that we can. So I'm going to make this y equals, I'm going to write it up here, 2x over x plus 3, x minus 3. Okay, those vertical asymptotes, remember, they're where the x values would make us divide by 0. So we just look at the denominator, and our vertical asymptotes would be at x equals positive 3 and negative 3. So our negative 3 is here, and positive 3 is about here. Great. Okay, horizontal asymptotes. Remember, when you're looking for horizontal asymptotes, you're going to be comparing the degree. So I think I'm going to look at the original. The degree of the numerator is 1, because it's x to the 1, but the degree of the denominator is 2, x to the 2 down there. A little bit easier to see in that first version instead of the factored version. Again, since the degree of the numerator is smaller than the degree of the denominator, we have y equals 0 is our horizontal asymptote, just like in the last example. Great. Okay, let's talk about intercepts. So let's find the y-intercept. When we do this, we're going to set x equals to 0. So we have y equals 2 times 0 over 0 plus 3, 0 minus 3. So we have 0 over negative 9, which is 0. So we have the ordered pair 0, 0. Okay. Now when we go to find the x-intercept, we're going to get the same thing. We set y equal to 0 here. We would have 0 equals 2x over x squared minus 9. And when we cross multiply, we just have 0 equals 2x we've got x equals 0. So we get the same point again, which isn't very helpful at first. But remember, this is our only x or y intercept. This location at 0, 0 is the only place they can cross the x and y axis. So we know that our graph can't do this because it would cross at a different spot. It can't do this because it would cross here. So that's actually really informative to know where the x-intercept and y-intercept is in the only locations. But let's plot a few more points. So let's plot, let's plot things to the right and to the left of the asymptotes. So let's plot, say, at x equals -10 to start. So y equals 2 times -10 over -10 squared minus 9. I'll plug it into the original because there's only one x in that denominator. That gives us -20 over 100 minus 9. Now, just like in the last example, I don't care so much that the number is -20 over 91 and where is that as a decimal. What I care about is this is negative. Since I'm at way over here at x equals -10 and I have a negative y value, I know I'm down below the x-axis. I also know that my graph cannot cross and go up because I know that my only x-intercept is at 0, 0. So I know the graph must look something like this. It must get sucked towards those green and red asymptotes, and it can't cross the x-axis. Okay, let's pick another one. Let's pick a value in here between -3 and 0. So let's pick x equals -2. So y would be 2 times -2 over -2 squared minus 9. -4 over 4 minus 9. -4, -5 is positive 4/5. I care less about what that number is and more about the fact that it's positive, so it's up here. I know that I have to have the graph obey the asymptote, so it has to go close to this red asymptote up here, and it has to touch 0, 0. Okay. I'm going to give myself a little bit of room erasing some of these. Let's plug in. What I don't know is, does the graph now go back up or does it continue to go down? So let's plug in x equals +2. So if we plug in x equals +2, we have y equals 2 times 2 over 2 squared minus 9, which is 4 over -5, which is negative. So I know the graph goes down here. And since it has to get, whoops, I wrote a plus, I meant a minus. Since it has to go to that asymptote, I know it gets closer and closer to that x equals 3 asymptote. And one final problem, let's pick x equals 10. I don't think I'm going to fit that in very clearly, so I'm going to get rid of this. Pick x equals 10. Plug it in. We've got 2 times 10 over 10 squared minus 9, which is 20 over 91, which is positive. So the graph is up here at x equals 10. Knowing it can't cross the x-axis and it has to obey those asymptotes, there's a good idea of what my graph looks like. Let's do one more example. One last example. Let's graph y equals x plus 1 over x squared minus 2x minus 8. So just like the previous two examples, we'll factor our denominator. So we have y equals x plus 1 over x minus 4x plus 2. And we can tell pretty quickly then that our vertical asymptotes from our denominator are going to be at x equals 4 and x equals -2. So there's x equals 4 and x equals -2, vertical asymptotes. Just like in the last examples also, The degree of the numerator and the degree of the denominator are what we're going to look at for our horizontal asymptotes. And since the degree of the numerator is smaller, it's only 1, than the degree of the denominator, which is 2, then I have y equals 0 as the horizontal asymptote. So we'll plot that in there. Great. Okay, let's find our intercepts. So y-intercept, we're going to set x equal to 0. When we do that, I think I'm going to use the factored version. Y equals 0 plus 1 over 0 minus 4, 0 plus 2, which gives us 1 over negative 8. So at x equals 0, y is negative 1/8. And for the x-intercept, we're going to set y equal to 0. So we would have 0 equals x plus 1 over x minus 4 times x plus 2. And multiplying both sides by our denominator just gives us 0 equals x plus 1, so x equals negative 1, which is right here. Okay, great. So let's find a couple of more points. First thing we want to find, excuse me, starting on the far left, x equals negative 10. So that would be negative 10 plus 1 over negative 10 minus 4, negative 10 plus 2, negative 9 over negative 14, negative 8. And again, I'm not going to get so caught up in what that number is. I know a negative divided by a negative and another negative is going to give me a negative number. So way over here at negative 10, I know I'm going to be down below the x-axis. And if my graph has to behave according to those asymptotes, then the graph should look something like this. Okay, I should technically plug in something here. Oh no, I'm sorry, I do not need to plug in anything. Well, I should plug in something right here because I don't know whether this graph goes up or the graph could go up and come down. So I'm going to plug in x equals negative 1.5. And again, I'm just worried about the sign. So negative 1.5 plus 1, negative 1.5, minus 4, and negative 1.5 plus 2 would be y equals, let's see, negative 0.5 divided by a negative and a positive. A negative divided by a negative will give me a positive, so I know the graph goes up. Now, here's what I know that I don't need to plug in, say, x equals 3. I have enough information here. I know the graph comes down to negative 1/8. It cannot turn back up because that would be another x-intercept. So, and I would have found that in the previous step. So the graph must continue down, finding that asymptote. And then finally, something nice like x equals positive 10. I have y equals 10 plus 1 over 10, minus 4, and 10 plus 2. 11 over 6 times 12. All I really care about is that it's positive, so it's up here. So the graph must look, if it has to live up there, like this. All done.